Hello everyone, I'm Sam. Today the topic is demography. I think most people know about demography mainly from the census that happens every 10 years. The government sends people to collect detailed information about individuals and families. This info includes things like age, gender, whether you're married or not, where you were born, where you live, education level, your job, and your salary, etc. To protect everyone's privacy, the information is shared without showing anyone's identity. With this information, the government can make or change public policies like education, healthcare, transportation, and housing to better meet people's needs. In modern demography, there are three basic things: birth rates, death rates, and migration. Why do governments or other groups count the number of people? Today, let's talk about the history of demography. The term demography originates from the Greek word demos, meaning people or population. Even though we've had this word for many years, and counting people is not a new thing, the formal study of demography began in England in the 17th century. A guy named John Graunt set the stage for what we call demography. Back then in London, there were reports called bills of mortality that came out every week. These reports listed how many people died, what they died from, their age, and whether they were male or female. Local officials made these reports to keep an eye on diseases and try to stop them from spreading, especially to track big outbreaks like the plague. John Graunt studied these mortality reports and wrote a book called Natural and Political Observations Made Upon the Bills of Mortality, which included life tables. These tables helped him see patterns and trends in death rates that no one noticed before. For example, he found out that 1/3 of London's population died before they turned 16, showing that a lot of babies didn't survive. He also noticed that even though more boys were born, they were more likely to die young, which eventually balanced out the number of men and women. His life tables also estimated how many people lived in London, how many families there were, and the chances of surviving. At the time, London was facing a plague outbreak. Graunt used his data to figure out that the plague was mostly spreading through the air and was a major cause of death. His work got recognized, and after he showed his life tables to the King of England, he was invited to join the Royal Society, which was a big deal. This showed that people valued his work in understanding population changes and death rates. At the same time, another British economist named William Petty talked about his views on death rates in his book, Treatise of Taxes. He said, "We can figure out how many people get sick in London by looking at the numbers of deaths. Then we guess how many people are sick in the countryside based on the city's sickness rates. After that, with advice from medical experts, we can estimate how many doctors the whole country needs. This helps us decide how many students should study to become surgeons, pharmacists, and nurses. By doing these calculations, we could weed out the doctors who aren't good enough." William Petty showed his forward thinking in early statistics and public health. He used death rate data to help organize medical resources and improve public health policies, aiming to make healthcare more effective and improve the quality of medical education and professions. Back in the 17th century, during the time known as the Scientific Revolution, math and statistics started to be seen as key tools to understand the natural world and human society. Scientists like Galileo, Newton, and Kepler used math to explain how things in nature work, showing that math is really important in finding out the rules of nature. They discovered that nature follows patterns that we can predict with math, and we can figure these out experiments and calculations. At that time, countries began to use numbers and stats to study and predict things about people, like how many are born and how many die. About 100 years later, in 1798, Thomas Malthus published a book called An Essay on the Principle of Population. Malthus discussed how rapidly the population grows in comparison to the food supply. What does this mean? Malthus said if we don't control the number of people, the population will grow really fast, like 1, 2, 4, 8, 16, but food will only increase slowly, like 1, 2, 3, 4, 5. This difference in growth could lead to not having enough food for everyone, causing hunger, disease, and other problems. Malthus also mentioned something called preventive checks. These are steps people take on their own to limit the size of their families, like marrying late and having fewer children, to prevent their families from falling into poverty. He thought these actions could help reduce population pressure and improve everyone's quality of life. However, some of Malthus's predictions didn't fully come true because of advancements in farming technology and modern birth control methods. A big change was in farming. In the old days, farming depended a lot on human and animal labor, which limited how much food could be produced. But modern farming uses machines like tractors, harvesters, and automatic seeders, which greatly increase how much food can be grown. Also, with the spread of condoms and birth control pills, people can control how many children they have more effectively. This means that Malthus's gloomy predictions about population growth didn't completely come true. While Malthus's theories were important insights at the time, technological and societal developments have updated some of his assumptions. Just now, I talked about some people who shared their thoughts and theories on birth and death rates. Is there a way to describe death rates in population studies using math? Turns out, yes. Back in 1825, a British guy named Benjamin Gompertz came up with a math formula. This formula shows that as people get older, their risk of dying goes up. Today, we call it the Gompertz law of mortality. In simple terms, Gompertz believed that the chance of dying increases exponentially with age. This means as you get older, the risk of dying grows at a constant rate. His theory pointed out that age is a key factor in how likely it is for someone to die. It's important to note, in Gompertz's model, the death rate doesn't just steadily go up over time. Instead, it speeds up as time goes on. The Gompertz model is fundamental in actuarial science, offering a strong framework to predict death rates. This information helps with life insurance and retirement planning. However, keep in mind that our bodies generally start aging around 30. Gompertz's law might not accurately predict death rates for very young people. Also, this formula doesn't consider other important factors that can significantly impact death rates, like genetics, accidents, and infectious diseases. Ignoring these factors could lead to inaccurate predictions of death rates. Therefore, 40 years later, a British actuary named William Mackham improved Gompertz's model. He added a constant number that doesn't change with age to make the model more accurate. Mackham realized that predicting death rates based only on age overlooked other important factors. By adding this constant number, we can account for factors that don't directly relate to age but still affect how long people live, like genetics, accidents, and diseases I mentioned earlier. In the 19th century, Europe wasn't very clean, especially during and after the Industrial Revolution. Cities grew fast, and this caused a lot of health problems. People lived in crowded places. There wasn't good sewage treatment or clean drinking water. Because of this, many people got sick from drinking contaminated water, spreading diseases like cholera. Then, people started to wonder, can we solve public health issues by looking at death rates and environmental data? During a cholera outbreak in London in 1848, some areas had much higher death rates than others. An epidemiologist named William Farr studied a lot of data, especially on deaths and water quality. He found that cholera cases were strongly linked to the water supply. He discovered that the affected areas mainly got their water from two companies, both using the polluted River Thames. Farr's work showed a direct link between the water source and cholera cases. He then called on water companies to improve their water quality. In 1853, when cholera hit London again, Farr analyzed the death rates and found that areas with improved water supply had lower death rates compared to nearby areas. As we started fixing these social problems, people turned their attention to new things like migration, a topic that few people had really studied before. Before the 19th century, not many people talked about immigration because it was hard to collect data. Traveling wasn't easy. This made it hard to see the real impact of people moving around. In 1885, a man named Ernst Georg Ravenstein came up with some rules about how and why people move, which later got known as Ravenstein's laws of migration. His work was really important for understanding why people move from one place to another. There are some basic concepts of Ravenstein's laws of migration, like the main reason people move is for a better job or to make more money. Also, he noticed that big cities attract more people than small towns or countryside areas. Ravenstein's ideas helped set the stage for later studies, and as time went on, people began to look at a bigger picture that included not just why people move, but also things like birth rates, death rates, and how populations change over time. In the 20th century, people studied how the number of people born and died changed in places like Europe and North America as societies moved from farming to industrial economies. They developed a theory called the demographic transition theory to explain how a country's population changes over time, especially how births and deaths shift as a country develops. The first stage is pre-industrial society. Think of the old times like the Middle Ages or before the Industrial Revolution. Both birth and death rates were high. Many babies were born, but sadly, many people died young, mostly due to diseases, hunger, and lack of medical knowledge. The population stayed the same size since a lot of people were born, but just as many died. The second stage is transition stage. This stage began with the Industrial Revolution, or when a country started developing. With better healthcare, improved sanitation, and more food, the death rate dropped sharply. But the birth rate remained high. So the population began to grow quickly. It was like suddenly people lived longer, but families still had lots of children. The third stage is industrial society. Now the country is becoming more urban and industrial. People start having fewer children because raising kids in the city is expensive. Also, women begin to work outside the home. The birth rate starts to drop, but since the death rate is already low, the population still grows, just more slowly. The fourth stage is post-industrial society. The country is now highly developed. Both birth and death rates are low, so the population is stable or grows very slowly. Families are smaller, healthcare is great, and people live longer. This is when a country enjoys modern comforts and technology, focusing more on personal and economic development. By understanding the four stages of the demographic transition theory, we can see how the structure of society changes with economic and industrial development, leading to shifts in birth and death rates. Since the 1950s, some countries have tried to change the number of babies born using different rules and plans. For example, since 1952, the government of India has been working on slowing down the growth of its population. They encouraged having fewer children and promoted surgeries for permanent birth control, but these efforts didn't reduce the birth rate by much. By the 1970s, only a few couples were using birth control methods. The plan didn't work well because it was hard to manage in a country with many languages, religions, and customs, leading to poor results. Because of these challenges, in 1976, Indira Gandhi's government decided to enforce stricter rules. These forceful actions sparked major protests and led to Gandhi's party losing the 1977 elections. As a result, India's family planning program faced significant setbacks. In 1965, Romania, like many countries in Eastern Europe, had fewer babies being born and its population was getting smaller. The leader at the time, Nicolae Ceausescu, thought the country needed more people for the army and factories. So in 1966, the Romanian government started encouraging families to have more children. This included making it really hard to get an abortion unless it was under very specific conditions, and they gave extra money to families with many kids. They really restricted abortion and birth control, which led to more babies being born between 1965 and 1970. But then, the number of babies being born started to decrease again. So in 1984, the government tried a new plan to increase the birth rate and make abortion even harder to get. Women of childbearing age had to go through regular checks at work, and there was a special tax for single people over 25 and married couples without children. By 1985, only women over 45 who already had at least 5 children could legally have an abortion. These changes in birth policies show how different countries tried to deal with population issues and how these policies evolved over time. Later, demography developed other branches, like paleodemography. Paleodemography mainly tries to understand the population growth, structure, life expectancy, and death rates of ancient times. One big challenge in paleodemography is the lack of direct population data. Unlike today, where we can easily get detailed census data, ancient populations left limited and often indirect evidence of their characteristics. This means we have to use proxy data, like cemeteries and human bones, to estimate the size and trends of these ancient populations. Demography also looks at other areas like family demography, which focuses on the structure and changes in families. There's spatial demography that studies how populations are spread out geographically, and mathematical demography, which uses math models to analyze population trends. These fields are broad, and each one uses its own unique methods and perspectives. This helps us get a complete understanding of population changes and their effects on different parts of society. Why do demographers study population trends? They do this because changes in the number of people affect our society, economy, politics, and environment. Knowing how the population changes helps governments and organizations make plans and decisions to deal with more or fewer people, aging, people moving from one place to another, and cities growing. The United Nations 2022 World Population Prospects Report, it said, for high-income countries between 2000 and 2020, the contribution of international migration to population growth exceeded the balance of births over deaths. Over the next few decades, migration will be the sole driver of population growth in high-income countries. By studying these trends, demographers find out how immigration is a big reason for population growth in wealthy countries. This is very important for making policies and planning for the country's future. The report also talks about aging populations. By 2050, in Southeast Asia, Europe, and North America, 1 out of every 4 people will be over 65 years old. Many developed countries are facing the challenge of an aging population. This is why the work of demographers is important. They study how more older people can affect things like society, healthcare, and the job market. Understanding population is key to predicting and shaping the future of society and the economy. By looking at trends in births, deaths, and migration, demography provides vital information for making decisions that improve social well-being and economic growth. It also looks at how population changes affect the environment, city growth, and global migration. Demography is the key to unlock solutions for current challenges. That's all for today. If you're interested, check out my other videos. I'll see you next time.